Algebra, graphing, finding time in a free fall problem. Let's learn physics. Quick free fall problem today, focusing on the algebra, the positives, the negatives, the equations. So here's the situation. 3 kilogram ball thrown down at 30 meters per second. That's you, right? From a 50-meter height. There is the height at 50 meters. 30 meters per second, that's like 65, 70 miles an hour. 50 meters, like 150 feet. It's about 50 yards, close enough. Find the time to the bottom and the final velocity. Now first, do you have to solve the part A first? Time to the you don't. You don't. You could solve for the final velocity. If you find the final velocity to solve easier, then find that. And once you found one thing, then the other thing is easier to find. You have more options for all the equations. We're using the kinematics equations. The average velocity is displacement over time. Acceleration is delta v over t. Vf squared is equal to vi squared plus 2a delta x. Delta x is equal to vit plus 1/2 at squared. Here's the situation drawn right there. Initial velocity is 30 meters per second. Acceleration is negative 10 meters per second every second. And the displacement is 50 meters. Do you see the problem? Do you see what I missed? Do you see what you are going to miss also? Now, in this situation, down is negative, up is positive. Thrown down, oh, that's in the same direction as the constant acceleration of gravity. So if you're using down as negative and up as positive, this velocity is also a negative value. And if you're using down as negative, up as positive, you have to be consistent all the way through. And so here, this becomes your zero. Above that for the displacement is positive. Below that for the displacement is negative. And this 50 meters, that's negative. Or you could just say down is positive and everything becomes positive. Either way. But if you want to be consistent, which helps a whole lot, if you're consistent all the way through all the problems, especially when you're first solving these things, this is how you do it. So you look through, you're like, okay, delta x, t, acceleration, initial velocity, which equation? You look through your list of equations to see which one equation has that peculiar combination of variables, and you realize that, oh,
delta x is equal to vit plus 1/2 at squared. That's the one equation that fits that.
And I can solve for the time. And then you're like, oh, I don't know if this is going to be convenient. Anyway, put the numbers in. Negative 50 meters is equal to the initial velocity, negative 30 meters per second, plus 1/2 times 10 meters per second every second times time. And you'll notice already, these are mistakes that you will make. T squared. You're going to drop that. You're going to drop that t squared. You're going to pretend that the t squared and the t, even the t, I even dropped the t. This the t, there's a t term, there is a number term, sheesh, there's a t term, there's a number term, and there's a t squared term. And you're not going to copy negatives. So you'll forget a whole bunch of stuff when solving this thing. I should have written that a little bit better, whatever. So negative 50. Now to make this more like a math problem, because math problem never has units in it, so you can see it more easily, I'm just going to drop the units. Negative 50 is equal to negative 30t minus 5t squared. And then you're like, oh, look at that. That's like a second order polynomial. And that I think I can use the quadratic formula, because I love the quadratic formula. The t is of course equal to, well, let's order it properly first. 0 equals negative 5t squared minus 30t plus 50. So this is ax squared plus bx plus c. So x, or t in this case,
t is equal to the opposite of b plus or minus the square root of the quantity b squared minus 4ac all divided by 2a.
and that is a ridiculous and stupidly inconvenient problem that you don't actually want to solve that way. Where's my calculator? Here's my calculator. So this thing right here, all you have to do is graph it and find the zeros. Let me show you how to do it. You grab the calculator, part of your science kit, turn that thing on, hit the y equals button, and then take that equation that you have.
Negative 5 xt theta, etc. And hit that little x squared button. Don't use the caret 2 in this case. Minus 30t, minus 30t x. And then plus 50, plus 50. And then you can graph that thing.
And you get something that looks like that. Goes up here, down there. Now this is just from like here down. That's what you want. and you can change your window if you want to, so it's a little bit different. You can zoom the thing so it's a bit different, but what you want to do, second function, calc, right there. Oh, I want to find not the value, but the 0. I want to find the 0 there, and then I can, it says left bound, right? So left bound, I have to move this over, and this is -10, -8, -7, negative, I'm looking for positive, positive, where is this thing? See the y value? It shows the y value. It is right about, where's my cursor? There it is. Oh, look at that. So you have to bracket where it crosses. That is left of where it crosses. This is the one you want, not this one. This is on the way down. And hit enter for the left bound. And then I have to move this cursor to the right where the y is negative. Hit enter again, then guess, whatever. And then it'll calculate for you 1.36 seconds. 1.36 seconds is where it crosses right there, and that is your answer. So using the calculator, you got a 1.36 seconds. And then 1.36 seconds total from here down to there till just before it hits the ground. The problem starts when it's released, and the problem stops just before it hits something else, because the acceleration has to be a constant g, -10 meters per second every second, or if you're being a little stinky about it, -9.8 meters per second every second. Now we're going to look for the final velocity. And you're like, oh, I got to set this whole thing up again, right? So you could set the whole thing up again. Initial velocity, acceleration, displacement. Time is 1.36 seconds. VF equals, and then you look through all your equations. You're like, oh, VF is equal to VI plus AT. I can solve that. I can use that one. VF squared is equal to VI squared plus 2A delta X. I can solve it with that one, but you know what else you could use? You could use your little noggin. You could use your dome. You could use your skull. You could use your brain, and you could just think about it because, well, all right, well, this thing's traveling 30 meters per second at the beginning, and it's accelerating, speeding up. It's on the way down, right? Speeding up at 10 meters per second every second. It's about 22 miles an hour every second. It's a pretty good acceleration. And then travels for 1.3 seconds before it hits the ground. Well, of course, I'm just going to add 10 times 13, 13.6. It adds 13.6 meters per second. And so final answer here, a little faster, 13 plus 30 plus 13.6 gives you 43.6 meters per second. Down is the final velocity. Think through it. Some of these things are pretty quick. Think through it, figure it out. Algebra, think. All right, that's it. Thanks for watching Learn Physics. And thanks for that thumbs up too. Really helps a lot. New videos most academic weeks. Subscribe for more. I've even got education ideas, Freaky Physics Friday, and Tech Tip Tuesday. And for bicycles, motorcycles, and family adventures, it's my other channel, Bike Physics. You just learned physics.